Okay, so the next question that we have here is somewhat related to geometry and also analytical geometry. So you have basically, the question is, in the triangle ABC, you have a triangle ABC. You have this triangle ABC, and the vertices are A 2, 3. B is basically 4, -1, and C is basically 1, 2. We want to find the equation of the altitude from vertex A. So if you plot this triangle over here in an XY plane, you will get 2, 3, which is basically this point over here. 4, -1 is 1, 2, 3, 4, -1 is this point over here. And 1, 2 is basically this point over here. So your triangle is going to be this triangle over here. So this is 1, 2. This point is C. This point 4, -1 is basically point B. And 2, 3 would be this point over here, which is A. Now from this I cannot really tell. For example, the length of the perpendicular might actually be the length of side AC, or it might be a little bit different. Now, just for the sake of basically demonstration, I draw some line segment over here, meaning that there is a line segment drawn from the vertex A to this base BC, and this line segment is perpendicular to this side, and that is called basically an altitude. And this over here is called an altitude. It's called an altitude. So an altitude is basically, in geometry, if you have some triangle like this, suppose that you have a triangle right here, and if this is, for example, ABC, a line segment drawn from any vertex, for example A, to the opposite side, which is perpendicular to the opposite side, is called an altitude. Is called an altitude. And so you have basically one altitude over here, one altitude over here, and you have one altitude over here. And of course they are supposed to meet at one point. If you do them properly, if they are exactly 90 degrees, they are supposed to meet at some point, whether sometimes outside the triangle, sometimes inside the triangle. But that's basically what an altitude is. Now, since you want to calculate the length of this altitude, so basically you can find the coordinates of the point A. You already know that's 2, 3. But the coordinates of this point over here, if I call it P, for example, if I call this point P, then the coordinates of this point you don't know. And so we need to figure that out first. So in order to do that, what we can do is that first find the equation of the line BC, and then based on that we can find the equation of the line AP, or the line segment AP, and then we can do the rest of the things. So the equation of the line BC for the equation of the line BC. So you have basically the coordinates of B is 4, -1, and C is basically 1, 2. So we can calculate the slope over here. The slope over here is basically m, let's call it m1 for example, is equal to y2 minus y1 over x2 minus x1, which is equal to 2 plus 1 over 1 minus 4, which is equal to 3 over -3, which is equal to -1. So the slope of this line BC is equal to -1, or m1 is equal to -1. And also you know that y minus y1 is equal to m times x minus x1. So I take m as -1, or m1 as -1, and one of the points over here, for example 4, -1, as one of the points x1, y1. So then I can find the equation of the line, meaning that y minus or plus 1 is equal to -1 times x minus 4. So that means that y plus 1 is equal to 4 minus x, or you can say that y is equal to -x, and this is 4 minus 1, which is equal to 3. So this is the equation of the line BC. This is the equation of BC. So now that you have the equation of BC, you can, based on that, you can find the equation of AP. So since you know that basically the equation of the line, basically AP and BC are perpendicular, if I call the slope of AP M1, so the slope of AP, I call it M1, then I can say that M1 times M2 is equal to -1. Now M1 is equal to -1 times M2 is equal to -1, which means that M2 is equal to 1. The slope of AP has to be +1, and of course one point on AP is 2, 3. So 2, 3 is 1 point on AP. So this is to find the equation of AP. This is 1 point on the line, and this is the slope. So y minus y1 is equal to m times x minus x1. So then you can write y minus 3 is equal to 1 times x minus x1, x minus 2. That means that y is equal to x, basically 3 minus 2 is equal to 1 plus 1. This is the equation of AP. Now we know that these two lines, this one over here, so the equation of BC over here is y is equal to -x plus 3. This is the equation of BC, and we know that these two lines meet at some point over here. AP and BC meet at this point over here, P. So if I find that point of intersection, that point will be the point P over here. So if I write basically y is equal to x plus 1 and y is equal to -x plus 3 and form a system of equations in two variables, if I add these two equations together, I'll have these two cancelled out, and then 2y is equal to 3 plus 1 is equal to 4. That means that y is equal to 2. That means that y is equal to 2. Now you know that y is equal to x plus 1. Now if y is equal to 2, x plus 1, so that means that x is equal to 2 minus 1, which is equal to 1. So that means that the coordinates of the point P is 1, 2. Is 1, 2. So the point P over here, the coordinates of the point P, P is 1, 2. Now you want to find the length of the altitude from vertex A from the vertex A to the basically to the base over here. So the length of the altitude is basically these 2 points over here, A2, 3. So you have A2, 3, and P is basically 1, 2, and the altitude is between these 2 points. So if I find the distance between these 2 points, that will be the length of the altitude. So what I can do is that the distance formula, we said that AB is equal to the square root of x2 minus x1 whole squared plus y2 minus y1 whole squared. And so based on this, AP is going to be equal to basically x2 minus x1. So you have 1 minus 2 whole squared plus 2 minus 3 whole squared. And so that is equal to negative 1 whole squared plus negative 1 whole squared, which is equal to basically 1 plus 1, which is equal to the square root of 2. So that means that the length of AP is equal to square root of 2 units. And that is the length of the altitude, which is question number 17. Question number 17, square root of 2. Now question number 18. Question number 18 is if P is the length of perpendicular from the origin to the line whose intercepts on the axis are A and B, then show that basically 1 over P squared is equal to 1 over A squared plus 1 over B squared. So if P is the length of perpendicular from the origin, P is the length of perpendicular from the origin to the line whose intercepts on the axis are A and B, you want to show that 1 over P squared is equal to 1 over A squared plus 1 over B squared. Okay, so basically to solve this problem, I did try to solve this problem in a specific way, but it didn't actually, it turned out to be a little bit different from what I wanted to do. So we do need to do it in a different way. So basically this is the question, and so basically what the question is asking or is saying is basically the length of perpendicular from the origin to this line whose intercepts are on the axis are A and B is P. So you want to show that basically 1 over p squared is equal to 1 over a squared plus 1 over b squared. Now you know that the equation of a line whose intercepts on the axis are a and b are basically x over a plus y over b is equal to 1. That you already know. Of course, it's not here given which one is the x intercept, which one is the y intercept. I'm assuming that a is the x intercept and y is the y intercept. Otherwise, you would have to write this equation as y over b plus x over b plus y over a is equal to 1 if this was different. Otherwise, I'm just making an assumption here. And so if you simplify this equation, you will get, if I multiply by AB, I get x times AB over A plus y times AB over B is equal to AB. And then these two will cancel out, these two will cancel out. You will have bx plus ay is equal to AB. Or you can write this as bx plus ay minus ab is equal to 0. Now you know that the perpendicular distance from any point, so you know that the perpendicular distance from any point, for example x1 y1 to some line ax plus by plus c is equal to 0 is basically which we usually call d, is basically the absolute value of a x1 plus by1 plus c over the square root of a squared plus b squared. So now if you basically compare this equation to this equation, you can see that basically your a over here, your a is equal to the lowercase b, your b over here, and this is supposed to be capital B. So your b over here is equal to the lowercase a, and your c over here, is negative ab. And so and the point is the origin, meaning that the line is being drawn from the perpendicular to this line from the origin. So that means that x1 y1 is 0, 0. So then you can write so now if p is let's say that p is the length of the perpendicular from this point to this line, you can write basically p is equal to, based on this formula, ax1, which is going to be equal to 0 because x1 and y1 here are 0. So this becomes 0 and this becomes 0, and you have c over here, which is negative ab, the absolute value of negative ab over the square root of a squared plus b squared, which is b squared plus a squared, which is a squared plus b squared. Now if I square both sides of this equation, I'll get p squared is equal to negative ab whole squared, over a squared plus b squared, and so, and of course you can write this as p squared is equal to a squared b squared over a squared plus b squared, and of course 1 over p squared is the reciprocal of this, which is a squared plus b squared over a squared b squared. So 1 over p squared is equal to a squared plus b squared over a squared b squared. And well, I did solve the question, solve it in the exact same way. Now, if you write 1 over p squared is equal to 1 over a squared plus 1 over b squared. So now, if you write 1 over a squared, 1 over a squared plus 1 over b squared, it's going to be a squared b squared and a squared plus b squared, which is basically the same thing that I have over here. So I can write this as 1 over a squared plus 1 over b squared. That means that 1 over p squared, I don't know where I made the mistake the last time. 1 over p squared is 1 over a squared plus 1 over b squared, which is basically what we wanted to show over here. And that is basically what we wanted to show. 1 over p squared is 1 over a squared plus 1 over b squared. Okay, so we are done with these examples here. There are a few more things over here that we can discuss. There are some things called miscellaneous examples, and we have some miscellaneous exercises as well. I think I'm going to do all of these, and then we will get to the rest of the book. So I'll see you in the next video, and thank you.